Let's now continue writing our protect middleware function. So in the last lecture, we read the token from the authorization header and then checked if the token actually exists. So right here, okay? And next up, we have the verification step for the token, okay? And I hope you remember that in this step, we verify if someone manipulated the data or also if the token has already expired, okay? So we already used from the JSON Web Token package the sign function, and now we're going to use the verify function. All right. So just like before, jwt.verify, and then in there, as you can imagine, we pass the token so that the algorithm can read the payload. And then remember that this step also needs the secret. All right. So basically, in order to create the test signature. So that secret is at process.env.jwt secret. Remember that? Now, as a third argument, this function actually requires a callback function. All right. And so this callback is then going to run as soon as the verification has been completed. So you see that this verify here is actually an asynchronous function. All right. So it will verify the token, and then after that, when it's done, it will then call the callback function that we can specify. Now, we've been working with promises all the time, and I don't really want to break that pattern here, okay? And so we are actually going to promisifying this function. So basically to make it return a promise, all right? And so that way we can then use async await just like any other async function that we've been using, all right? So in order to do that, Node actually has a built-in promisify function. All we need to do in order to use it is to require the built-in util module. Okay, so let's do that right at the top actually. Okay, so that will create an object called util require. All right, so that stands for utility. That's not what I wanted. Okay, so that stands for utility. And then on there, we are going to use the promisify method. But since we're only going to use that one method, we can actually do it easier. Okay, so instead of doing this, we can simply destructure that object and take promisify directly from there. Okay, so again, this is just using ES6 destructuring. Okay. Okay, and so now it's very easy to use. All we have to do is to actually call promisify. So promisify, and then pass the function in there. Okay. And so now all this here is a function that we need to call, which will then return the promise. All right. And so here we then actually call the function, and this will then return the promise. And so we can await it and store the result into a variable. So that resolved value of the promise will actually be the decoded data. So the decoded payload from this JSON web token. So let me call it decoded here. All right. And we can do await because we actually already said that it's an asynchronous function. And now just to see that it actually works, let's log this decoded data to the console as well. And actually we can remove this console.log of the token. That one we no longer need. So let's try to send this request again. And yeah, but this time actually turning on this authorization header so that we send or JSON the web token along with the request. So let's send it. And now indeed we get access to the data. And so therefore we now have access to the protected route. Okay. But what I wanted to see is this decoded object here. Okay. And so this here should be the user ID. So let's take a look at that in Postman again. So 62A42. And so indeed, well, where do we have that? Let's take a look at Compass. And indeed, the ID of this user is this 62A42. Okay, and so that means that we actually have our correct payload here. So basically the correct user ID. We then also have the timestamp of the creation date and of the expiration date of the token as well. So this is working, but now let's actually try to manipulate the payload of this token. All right, so let's copy it here again. But then I'm going to the JWT debugger. So again at jwt.io. So let's take this away. And now what I'm going to do is to change some data here, and that will then change the encoded token here, which I can then go ahead and copy. So let's simply replace, or simply I will actually just replace these two numbers here with something different. And so as you see, this changed the token over here. And so now I will actually try to get access to that protected route using this manipulated JSON Web Token. Okay, makes sense? So just to see if it's working correctly. All right, so I'm copying this one here now and pasting this other different one. And so if I now send this request, then we get an error. So great. So we see the error name is JSON Web Token error, and we have an invalid signature. So great, that's exactly what we were looking for. So that is one of the two errors that can occur. The other one is that the token has already expired. All right. So this one is called JSON Web Token error. And so actually, let's go ahead and handle this error now. And the way we could do it is to add a try catch block right here, right? So right after doing this code, we could introduce a try block, and then in a catch, we would then create errors that would be sent to the client. Now, instead of doing it that way, I actually want to use our global error handling middleware in order to do that for us, all right? So we don't like to do error handling right here in our middleware function. Instead, we usually delegate it to the error controller. Okay, and so let's do that exact same thing here. So, error controller, and then it's actually the exact same thing as we have with our other errors here. So for example, the validation error coming from Mongoose, so from another library. And now this error is actually also coming from another library, and it also has its own name. So let's get that. And it's JSON Web Token error. All right. And so let's do very similar here. So if .name is this, then error should be equal to handle error. Okay. So let's go ahead and create this function actually somewhere up here. And this one is actually extremely simple. All it does is to take an error and then return a new app error. Okay, and so in this ES6 arrow function, as I hope you know, we can write these one-liners where we don't even have to specify the curly braces and neither the return keyword. So this will automatically and implicitly return whatever we put here, right? And so what we want to say here is simply invalid token, please log in again. And then the error code, just like before, is a 401 for unauthorized. All right. Now this only works, remember, in production. Okay. And so if we did this now again, then we would get the exact same thing. And so let's actually go back here and run this in production. So npm run start production. Yeah, just like that. So if we try this now again, let's see if we get our error. And indeed, we do. So if right now a user in production tries to access our app with an invalid token, well, then they get just this error message. All right. So that's the first error that we can get. But another one is that the user tries to access the application with an already expired token. All right. And so let's not try to create that error. Okay. And in order to do that, I will change the time it takes for the token to expire. Okay. So right now we have 90 days. So let's put it to like 5 seconds. Okay. Give it a save. And now try to log in again. So let's actually save this one here as well. So in users, and then log in. Okay, so we can log in and it will then give us a new token, but this token is only valid for 5 seconds. And so these 5 seconds should have passed at this point. So I will now copy this token and try to access our protected route using that token. So paste it here. And now let's see what we get. And actually, for some reason, it did work. So let's take a look at our JWT debugger again. And it says created May 2nd, but expires only in July 31. And so something went wrong in that token creation, I guess. And so let's change this here again. And I'm just going to put 5 here. Okay. And so that 5 should then stand for 5 milliseconds. Or I can even like put 5,000, which should then be 5 seconds. Okay. So let me save it here now again in order to restart the server. Try it again. So logging in again here. All right. And so now all we need to do is to basically wait 5 seconds. And that time should already have passed at this point. Paste it here again. And let's go. And indeed, we get an error. Now remember how this is basically the standard error that we get in case we do not correctly handle that error in our error handling, right? So let's just take a look at the error. And actually we have it here in the console. So let's see where that comes from. And yeah, it comes from this place. So this is the case in where we have an unknown error. Remember, so an error that is not marked as an operational error, and so therefore we want to log it. Okay, so we log it here, and then we send this generic error message down to the client, so the one that we just saw in Postman. But here we actually get the details from this error, and so this one has the name of token expired error. All right, and so let's now handle this one as well. So I'm copying it now, and then create just another if here. So if the error.name equals this one, well then let's say handle JWT expired error with the arrow. Okay, let's copy it and put it right here. And so this, of course, is very similar to the one before. Your token has expired. Please log in again. And again with a 401 error code. Okay, let's try that again. And so that's exactly the error message that we should now see here. All right, and indeed it is. So great, let's finish the process here and start it in dev mode, of course. So npm start, and all right. So this one we don't need anymore, so let's close it. Or actually let's fix this small error here, because indeed we do not use this error here at all. So let's get rid of it. And then down here, we don't need to pass it in there. Cool. We, of course, also need to change this back to 90 days. All right. And so just to be really sure, let's log in here again, copy the token, and put it here. Now this process here of copying the token and then pasting it here in this header may seem a bit weird. And actually we're going to fix that in one of the future videos, so that basically this process happens automatically. But now what's important is that it's actually back to working now. So we can actually get rid of this console.log here and move on to the next step. And we could actually stop here now if we wanted. And again, most tutorials that you're going to find out there would in fact just stop here. But this is not really secure enough just yet. So for example, what if the user has been deleted in the meantime? So the token will still exist, but if the user is no longer existent, well, then we actually don't want to log him in, right? Or even worse, what if the user has actually changed his password after the token has been issued? Well, that should also not work, right? For example, imagine that someone stole the JSON Web Token from a user, but then in order to protect against that, the user changes his password. And so of course that old token that was issued before the password change should no longer be valid. So it should not be accepted to access protected routes, right? And so that's the kind of stuff that we're going to implement here in step 3 and step 4. So the first thing to do is to check if the user actually still exists. And so that one should be the easiest one. So let's just say user.find by ID. And so this is now why we actually have the ID in the payload, okay? Because we can now use that ID and query the user using just that ID. So decoded.id, all right? And so that should then find the new user. And of course, we need to await that and then store it into a variable. And I'm calling it a fresh user, all right? Because it's not really a new user. That's only when we create one. But this is not really a new one. It's really just the user based on the decoded ID, okay? And we can do this so we can be 100% sure that the ID is actually correct, because if we made it until this point of the code here, then that means that the verification process that we have previously here was successful. Otherwise, this would have caused an error, which would then have prevented the function from continuing, okay? And so again, this verification process here is in charge of verification if no one altered the ID that's in the payload of this token, okay? And so because of that, we can be 100% sure that the user for which we have issued the JWT is exactly the one whose ID is now inside of the decoded payload. So this one, okay? So the verification process is really key, is really what makes all of this works. Anyway, now what we need to do is to check if there actually is a fresh user. And if not, well then, of course, we're going to return a new error, okay? So if there is no fresh user, then return from this middleware and call the next one with an error. So this is a pattern that we've been seeing over and over again at this point, right? So the token does no longer exist. And actually it's the other way around. So actually the user belonging to the token no longer exists, right? And then the 401. Okay, so let's test this one again, and let's actually create a new user for that. So just test with the same password, so we're always using the same one here just to make our testing a bit easier. And I know that all of this testing here makes the video take really quite a long time, but of course it's really important that we do test everything that we do, especially in such an important topic as authentication, okay? So I'm now using this JWT here, so I'm pasting it here, but of course before sending the request, I will go ahead and delete that user right away, okay? So again, let's pretend someone created a user, then logged in, and let's say then after some time the user was deleted. But in the meantime, someone could have gotten access to that JWT and could now try to log in as that user that was in fact already deleted. And so again, we should not let that happen. So let me delete this user here now. And there we go. And so let's test it now. And again, keep in mind that the user belonging to the ID, which is in this payload, is now no longer there. So let's see. And indeed, we get this error message that we just created. So that one is working as well. And let's so go to the last one. So step number 4, check if the user has recently changed their password. So basically after the token was issued. And to implement this test, we will actually create another instance method. So basically a method that is going to be available on all the documents. So documents are instances of a model, all right? And we do this because it's quite a lot of code that we need for this verification. And so actually this code belongs to the user model and not really to the controller. Okay, and so let's do that just like we did before for checking the passwords. So in user model, we already implemented this correct password static instance method, remember? And so let's now create another one. So user schema dot methods dot changed password after. So function, and into this function we will pass the JWT timestamp. So basically that timestamp which says when the token was issued. So let's call that JWT timestamp. Alright, and by default we will return false from this method, and that will then mean that the user has not changed his password after the token was issued. Okay, so let's put that here, return false basically by default. Okay, but then we also have if this, and remember that in an instance method the this keyword always points to the current document. Okay, and so therefore here we have access to the properties. Now we actually need to create a field now in our schema for that date where the password has been changed. So we don't have that yet. So let's quickly add it here. So password changed at, and the type of it will be a date. All right. Now this password changed at property here will always be changed, of course, when someone changed a password. Okay. So right now we don't have that logic anywhere, and so nowhere we are actually defining this property. Okay. And so most of the documents, so most of the users, they will simply not have this property in their data, so in their object, right? And so of course we need to test for that. Okay, so if the password changed at property exists, only then we want to actually do the comparison. Okay, but if not, so if password changed does not exist, well then that means that the user has never actually changed the password, and so therefore we can simply return false. Okay, so again, that's our default, meaning that the user has not changed the password after this timestamp. Okay, and now just to start, let's actually log to the console this dot password changed at, and then of course the JWT timestamp as well, just so we can see how we could compare them. All right. And now we need to actually create a user which has this property on it. Okay. And again, later in the section, when we will implement the logic for changing the password, is when we will then set this property. Okay. But now we will artificially basically set it here when we create a new user. Okay. So let's put that here, and here any date actually will serve. So let's say 30 April 2019 here, and so that should then be parsed into MongoDB just fine. Let's try that, see if it works. And that didn't work, so it couldn't really parse the date, let's say. And actually, I need to start with the year and then the day at the end. So 2019 and then 30 of April. Let's try that again. And so you see that now it's actually working. So we have this parsed date here. Okay. Now, in order to actually see the result of this, we of course need to call this method. Okay. So that's what we're going to do here in step 4. Okay. And so remember that we can call this instance method on a user document. So fresh user dot changed password after, and then that timestamp. So that's at decoded dot IAT, so issued at basically. All right, so let's simply see the result of doing that. And so of course this should now not here. So this should now log to the console these two values. Okay, now of course I need to log in with exactly this user, so with test. So here we go. Log in. Copy this token here again. And again, we're gonna basically automate that in the next video actually. Okay, paste it here. And now we actually get this bug here. So I just misspelled this function name here. Well, let's just copy it. Try it again. Oh man, what's going wrong now? And I see I simply forgot this log here. So another stupid mistake, probably saw that one coming. But now here we go. So everything worked fine. And all we really wanted to see for now is these two results. So we basically have this one here in this date format, and then the other one in this millisecond or second timestamp here. And so we now need to convert this password changed at also to a timestamp like that. All right. And so for that, let's create a new variable. So changed timestamp, and we can use this dot password changed at dot get time. Okay, and so that's one of the many date functions that JavaScript gives us. All right, and now let's quickly compare these two, because we're not quite ready yet actually. So sending it just to see the results here. And so what we see here basically is that this one here is now basically in seconds and this one in milliseconds. So it's 1,000 times more. And so we now need to divide this by 1,000 and then parse this entire thing as an integer. And for that, we use parseInt. So another JavaScript function that is available for numbers. And then we actually also need to specify the base. So this is a base 10 number. All right. And so now let's actually again see the result. And now that looks a lot friendlier. Okay, and so now let's actually return our result. And again, keep in mind that false means not changed. Okay, and not changed basically means that the day or the time at which the token was issued is less than the changed timestamp. Okay. So just as an example here, let's say that the token was issued at time 100. But then we changed the password, let's say at time 200. Okay. And so we changed the password after the token was issued. And so therefore this is now true. All right. And that's exactly what we want to return here, because false means not changed. And so true, of course, means changed. And so that's exactly what we have here. But now let's say that the password was last changed at 200. But then only after that we issued the token. So let's say at time 300. And so 300 less than 200? No, that's false. And so we return false, which again means not changed. And so that's why we use this less sign here. Okay? So let's go back to our controller and actually use this. So if the password was actually changed, well, in this case, we actually want an error. So return, next, again, a new app error. Recently please log in again. Okay. And once more, code 401. All right. So again, this will return true if the user actually changed their password. And so if all of this here is true, well, then exactly in that case is when we want this error to happen. All right. So that was actually the last step. Okay. So basically, if the code can make it all to the end of this code here, only then next will be executed. And then with next, we go to the next route handler, which effectively means to grant access to that protected route. Okay, let's actually put that here. grant access to protected route. Okay, because that's really all this next does. Next leads us to the next middleware, which is usually then the route handler itself. So the one which sends back the data that was protected. Okay, just one last thing that we want to do here is to actually then put the entire user data on the request. So we can simply say rec, so request.user will be equal to the fresh user. Okay, and again, of course, the code only ever reaches this point here in case everything is correct. Okay, and so this here might then be useful at some point in the future. Great, let's just test this one more time. And basically this change is in the past now. And so this token that we have here, or actually I could have used just this one instead of logging in again. But anyway, this token was issued after the password change. And so this token should now work. So let's actually log in again and try it with this token. And indeed, we get access. Now, moving to Compass in order to change that date. Okay, so let's put it 1 month later, and so that will actually be in the future, so at least in my future when I'm recording this video. Of course, you will be doing this at a later point, and so to test this, please put this in your future, okay? So in the future of the day where you're watching this video. So if I go now back to Postman and log in again, okay? So if I log in again now and try to access that route, well, then this token will be issued basically after the password has been changed. Or actually before the password has been changed. So sorry for that confusion. So the password was changed at May 30, but this token was issued at May the 2nd, and so before. So basically it's now as if the user had changed their password after the token was issued. And so that's exactly the situation where we don't want to give access to the protected route. And so this should now then reflect that. And indeed, user recently changed password. Please log in again. And great. So that now works. So our protect middleware is now completely implemented. Let's just get rid of this console.log here. Don't need that one anymore. And okay, so let's quickly recap. And this video is running very long, a bit longer than I expected, but it's really important to understand and to explain how all of this works and why it's important. And so I prefer that than doing these videos much shorter, okay? Of course, I could just write the code and then you wouldn't really understand what's going on. So this part we already understood. Then this part here I believe as well. So this is where the verification happens. So basically seeing if the token payload has not been manipulated by some malicious third party, okay? And since we then reach this code here, it means that no one changed the JSON Web Token, and so therefore we can get a fresh user. So basically we can get the current user. Let's actually call it current user. Why not? So here, here, and also here. Okay, so we can get the current user from that ID that was just decoded from the payload. Now, if the current user does not exist, so this is what we're testing for here, well, then in that case, we do not want to give access to the route and instead create this new error here. But if the user does exist, well, then we make it to point number 4, where we then check if a password change has happened after the token was issued, right? And if it did, then again, we create a new error. And if it did not, well, then we make it to all the way to the end of the middleware function, where we then assign the current user to request.user so that we can then use it in a next middleware function, okay? Because remember, this request object, this is the one that travels basically from middleware to middleware. And so if we want to pass data from one middleware to the next one, then we can simply put some stuff on the request object, and then that data will be available at a later point. All right, so that's it. This is a very sophisticated and very complete route protecting algorithm basically, but I think it's really important to do it as well as we can. Anyway, glad to see that you made it to the end of this big video, and I see you in the next one.